Great. Yeah,
Okay.
could see that. Thanks, John.
Yeah. So yeah, I'm John Kunze. Thank you, Nick. I'm a computer scientist who's been working with libraries, museums, and archives for the past 20 years. This talk includes examples from each of those sectors, but we're working for a library. I had to be aggressively sort of domain agnostic. So the things that I will be talking about apply across many domains, but there are use cases that go quite deep into specific domains. So this talk is going to be largely about identifiers, which certainly apply to vocabulary terms, which is more the subject of this community. Back in July, Chael hosted a meeting in which I talked about one of the applications of these ARK identifiers, which I'm going to talk about, called YAMZ, which is a vocabulary builder. I'll mention that as a use case later. But why don't we just dive in? In case you're wondering, a persistent identifier, or PID, serves the same purpose as a permalink. It's very rarely an identifier that is proven to be persistent, which would require a paper trail with extensive monitoring. So a persistent identifier, whether an ARK, DOI, handle, URN, or Perl, it's just an identifier that was aspirationally persistent when it was created. Why should we care about ARKs? The average lifetime of a URL was once said to be 100 days. At the end of its life, a URL link breaks, usually giving you the dreaded 404 not found error that most of us have seen. While that can be irritating, it's a minor disaster for memory organizations. So ARKs can serve as robust links for any kind of thing in any discipline. The ARK scheme is one of 5 so-called persistent identifier, or PID schemes. There's been a great deal of nonsense written about PIDs, some of which is described in a Twitter thread called 10 Persistent Myths About Persistent Identifiers. It's available at the link using this example ARK or the QR code next to it. PIDs are like permalinks that contain hints that they are different somehow from the average URL. Every URL is potentially persistent, but strangely, some people think it becomes a PID when it acquires some superficial syntax differences, such as the ARK colon in this example, or when you see the domain name DOI.org at the start of a URL. Syntax is neither magic nor a guarantee. It's never more than a suggestion that you might find this link to be more stable than the 99% of URLs that are produced without any thought for preservation. So-called PIDs break often and by the hundreds of thousands, which is a normal part of providing a preservation service. Committed service providers will even repair some of those links. So syntax doesn't make it persistent, but it may suggest that you're looking at a permalink, whether or not it's displayed next to the label permalink. Anyway, the nonsense was in full bloom in the late 1990s, but it polluted the debate about the 4 proposed PID schemes, and that's why the Archival Resource Key, or ARK, identifier scheme was introduced in 2001. Here's what an ARK looks like. At first glance, it's a URL that carries this internal label. To the right, the 5-digit name assigning authority number, or NAN for short, identifies the organization that created the ARK. Further right, the part after the NAN names the thing that the ARK is assigned to. To the left, the host name makes the ARK actionable, or something you can click on. It's also known as the resolver. ARKs are unusual among persistent identifiers in allowing organizations to run their own resolvers. The part starting with the ARK colon is the core globally unique identity. It doesn't depend on the host being available or on the future existence of the World Wide Web. In the previous example, you saw N2T.net, which is a global name to thing resolver. N2T is the main ARK resolver. So why doesn't it contain the letters ARK? Well, one goal of the ARK design was to break out of the silos and walled gardens surrounding many identifier systems. So what got built was this name to thing resolver, or N2T. The domain name n2t.net is good for short citation strings, and true to its name, N2T also resolves hundreds of different identifier schemes, and that's what Nick alluded to in the understanding we had with identifiers.org. ARK organizations include a wide variety of memory institutions, nonprofits, for-profits, data centers, and government agencies. A few are listed on this slide. What are ARKs used for? Here are some examples. The heaviest user of ARKs is the largest genealogical research organization called Family Search International. Next is the archive of all the source files for mainstream published content. Technically, they have over 40 billion ARKs, but apparently only 100 million of them are interesting externally. The French National Institute of Scientific and Technical Information uses ARKs in preserving datasets and supplemental information. Meanwhile, the Internet Archive has been assigning ARKs to scanned books and texts since 2008. The Smithsonian Institution is rapidly expanding their use of ARKs with a target of 100 to 150 million. I'll mention the French National Library, which was an early adopter, and here's a wonderful image depicting the biblical ark, and of course it has an ark. ARKs are also important for people, especially historical figures. For example, here's an ARK for the 19th century mathematician Ada Lovelace. Her ARK was assigned as part of the SNAP project, which is sort of like assigning orchids for dead people. Here's a brief case study for the French National Institute for Scientific and Technical Information. Their reserved NAN is 67375. On the right is one of its 22 million records, in this case, an entry from the SAGE Social Science Thesaurus. The tongue twister. Inside the red rectangle, you can see the ARK they assigned along with its man. Note how this ARK URL begins with their own resolver, not with N2T. It ends with an opaque string that tells us nothing about what it's assigned to, but we can tell from the metadata in the record that it's assigned to a conceptual thing. Here's another brief case study, this time for the Internet Archive's ARK implementation. Note their reserved NAN 13960. On the left is an example of a venerable library cataloging standard that has been digitized from paper and deposited in their text archive with an ARK. On the right is its metadata record, where you can see the ARK they assigned and its man inside the red rectangle. This shows what is called the compact form of an ARK, because it's just the globally unique identity without a resolver in front of it. In contrast to the identifier field above it, the ARK is opaque, which helps it age and travel well for external citation, even if it's awkward for backroom administrators. You can see a bunch of metadata above it that includes two URN identifiers that came in with it. Best practice is to preserve all the identifiers you find. Here's an abbreviated history of PID schemes. The Perl, which stands for persistent URL, fully embraced the URL. Meanwhile, URNs, DOIs, and handles got confused for a while, at first saying that all URLs are bad, until they later reversed that position and fully embraced the URL. Turning to the inventor of the web, he said basically, just use URLs and manage them carefully. The ARK approach agreed and said, go ahead and use URLs, but embed a distinguishing label to suggest that it's meant to be persistent and include a globally unique identity separate from the domain name and from today's web protocols. So here's the grumpy old man version or view of PIDs. Looking at this table, there's a big block of no answers in the first row, 4 rows. And they tell us that no PID scheme helps you with all of the major and most of the minor causes of broken links. So why even bother? Well, some of them are free. So there will be more money to spend on the real work of preservation. Here's a reminder for many of you that a core PID technique is indirect identifiers, which uses the web concept of redirects. So first, here's normal direct access. In direct access, a user clicks on a URL in a web browser, which sends it to the web server, appearing at the beginning of the URL, and a page is returned. With indirect access, the first server contacted says it doesn't know where the thing is, but it returns a message saying that this other named server should have more information. Behind the scenes, instantaneously and unbeknownst to the user, the browser restarts the process by contacting the second server. There could be a third server, fourth, fifth, etc. This is web redirection, and it's like forwarding snail mail to a new address. Many of our ordinary web accesses involve chains of multiple redirects, all taking place quickly and without the user being aware. If you buy into the idea that PIDs actually provide value, here are some details on things they might do for you. And by an amazing coincidence, this table is quite flattering to ARKs. The bottom line is always about cost. No organization pays for the right to create ARKs, URLs, or URNs in unlimited numbers. In the real world, or maybe just the academic world, PIDs that publishers use play a key role. When tenure and promotion hang in the balance, DOIs are the publisher's solution, and they are seen as a kind of badge of academic legitimacy. URLs are free and are common in the semantic web. URNs are useful if you're a national library in a nation that subsidizes URNs, and they have this unique advantage among PID schemes of having an internet standard behind them, even if it is frequently abused by creators of bogus URNs. Handles are popular in certain European projects, and they have a nicely replicated resolver infrastructure, which is also used by the DOI system. So they can be good if you can afford them. If you only have a couple dozen things to identify in a year, by all means consider going to zenodo.org and assigning your subsidized DOIs. That's much easier than implementing an entire ARK system. In summary, ARKs are similar to DOIs. They're both persistent identifiers for accessing content and metadata, and ARKs are found in many of the places where you'll find DOIs. In contrast, ARKs come with no fees, no limits on how many you can create, and no metadata requirements. From the beginning, ARKs were designed to be decentralized and to identify any kind of thing, digital, physical, or abstract. Finally, it's important to note that there is no conflict using both ARKs and DOIs at the same time. This is quite common. For example, you'll find a mix of both at the Smithsonian, British Library, and many other national libraries. Some outfits assign ARKs to everything, and for the subset of things that are later going to be published, they'll assign a DOI as well, where the DOI string can even be derived from the existing ARK string. Here's another use case, this one for the Smithsonian, whose NAN is 65665. I'm told by insiders that the technical challenge of implementing ARKs was minor compared to getting over a dozen internal organizations within the Smithsonian to actually work together. On this slide, you can see their NAN appearing at the beginning of each ARK. You can also see the wide range of object types, biological specimens, paintings, photos, and sculpture. Note the long opaque names they've assigned, which were generated using the UUID software that's pre-installed on nearly every platform. These unique names are long, unfortunately, but they're also very easy to generate. Very briefly, here's another view of the ARK syntax. It shows more detail than last time, but right now I just want to highlight the role of the NAN, or name assigning authority number. The NAN is a 5-digit number. As such, it is opaque, which is good for longevity. But what if you want to know what's behind the opacity? Well, in a browser's address bar, you can try truncating an ARK so that it stops after its NAN, as shown in the yellow highlighting. This is a stub ARK. If you hit enter after this incomplete ARK, it lets you inspect the 12148 NAN. You can also try this with any other NANs. Or you can try backing off even further to a shorter stub ending with just ARK colon, and that tells you about the ARK scheme. You can also replace that scheme with the name of any of the over 600 different schemes that N2T knows about, such as the protein data bank. All the NAN results that you can see by playing with stub ARKs in the address bar they're all pulled from the main NAN registry. This is just a plain text file that you can look at directly in your browser, or you can use the QR code if you're interested. Here's what it looks like when you ask N2T to tell you what the 12148 NAN is. You get the record for the National Library of France, as well as when it was registered in 2005, and very importantly, where the N2T resolver should redirect incoming ARKs so that they get sent to the correct resolver. So the NAN has two main purposes. It's a lookup key for the resolution reference point, and by defining the root of a global namespace, it isolates an organization's autonomy and responsibility for assigning its ARKs. That way, without interfering with anyone else's assignments, the organization can determine its own policies regarding identifier form, uniqueness, and reuse. Basically, just as with its URLs under its domain name, an organization can freely assign ARKs in any way that it wants. Here's a link to the form you can use to request a NAN for your organization. If you want to practice using it, go ahead, just indicate in the final comments that you're filling it out as a training exercise. A great deal has been written about opaque identifiers, which age and travel well, but they can be confusing because they reveal nothing about themselves to the user. One approach to soften the pain is to at least make them shorter and so a bit more citation friendly. The downside is that shorter IDs are harder to keep unique. One emerging trend is to use an opaque base identifier with lucid or non-opaque extensions. That can be okay because the extensions are actually more transient than the base thing itself. For example, image thumbnails are regularly upgraded to be higher resolution. This happens every few years to keep up with evolving demand and advances in storage capacity and in network rendering speeds. This slide lists some tools for generating opaque IDs, but I don't have time to get into them now. Back to details of ARK syntax. The special characters slash and period have reserved meanings in ARK suffixes. So that makes these characters effectively non-opaque. They help the recipient make inferences about one resource containing another, or one resource being a variant of another. In the regular non-ARK URL, you could guess at similar interpretations, but in ARK-based URLs, the guesswork is gone. If you use the reserved characters, you are formally declaring that these relationships exist. There's a natural parallelism between ARK suffixes and the popular IIIF image API. It's the International Image Interoperability Framework. That IIIF API is gaining traction in organizations that have lots of images, such as medical research, museums, and botanical gardens. IIIF works well for addressing hierarchical subregions and variants. And this leads to the next case study, this time for the French National Library, whose NAN you've seen. Here is a IIIF compliant URL. It requests the return from page 29 of a specific rectangular region. Reading from left to right and starting from the opaque base ID, you can see the page number here shown as F29 between slashes, followed by a comma-separated list of coordinates. Out at the end, you can see the request specifying full quality, and in this case, the JPEG format. So ARKs are very flexible. You can throw them away when something doesn't work out, with the big caveat This is much easier if you have never told anyone about them. If you don't tell anyone about your ARKs, it's like they never happened. Note that ARK metadata is also uniquely flexible, from none to schema.org to any profile of that to anything. So for example, starting in the planning phase, a thing needs an identifier before it exists, just so we can talk about it. After all, we name our children before they're born. Then at the moment of birth, when you've created a thing, that's when we might assign a redirection target as the one and only piece of metadata at that time. Later, we can gradually add draft metadata, which can then be reviewed and edited and cycled back. And this continues on through the life of the object. Persistence is not on or off. It's nuanced. Ironically, preservation often involves change. Valuable objects tend to be complex, human-curated clusters of digital artifacts that curators are forced to change in order to keep up with changing technical, policy, security, and even legal requirements, as well as with user expectations. This seems to surprise a lot of people, but it's common in people who are actually curating valuable content. So an ARK should lead to three things: to the identified thing, whether it's digital, physical, or conceptual. It should lead to metadata about it, answering at least the basic who, what, when, where questions, and to a nuanced persistent statement that sets expectations about what might change the next time you visit. Here's an example showing an ARK metadata request, which is created by appending a query string consisting of !info. The last line says that persistence information is unavailable for this particular record. !info is an example of an ARK inflection. An inflection is a grammatical device to change the meaning of a word by making small changes to the end of the original word. One advantage is that you don't have to assign and manage a completely separate identifier for the object and for its metadata. Instead, you just inflect the original ARK. So there is no harm with ARKs in using content negotiation as well, but the inflection mechanism is more transparent and more flexible. There's been a debate about requiring PIDs to cite a landing page rather than a directly usable PDF, image, spreadsheet, etc. This is a painful choice. It is often seen as if either you give up metadata access or you give up direct PID access to content by sending everyone to a landing page. Both outcomes are kind of terrible. In the ARK inflection world, you could imagine inflections for a landing page versus something called a plunging page. Every server can already provide either experience, so why not allow users to ask for each experience explicitly? Provider could be queried to return for any given identifier, either a landing page experience or an immersive sub-landing page experience. This might offer the best of both worlds. This use case describes work that I presented last July, thank you, Kyle, and that is supported by the Metadata Research Center at Drexel University. Note that the NaN here is more than a number. It has extra characters on the end, namely /H1, that is known as a shoulder, and that term comes from locksmithing jargon. Why would we want ARK identifiers for vocabulary? Well, linked data and semantic web applications are more valuable with permalink URLs or PIDs for their concepts for spreadsheet column header names, any control values under those names, relationships, pick list values, etc. Thousands of work groups across the world are inventing vocabulary or modifying existing terms, but they don't have easy ways to share and get feedback on the changes. So YAMZ was created by the creators of Dublin Core Metadata, who saw a need for an aggressively domain-agnostic tool that helps people reach consensus quickly on whatever metadata profile they're working on. So YAMZ is addressing that need, and here's a quick a slide too that shows how. It lets anyone look up terms to reference. You can also log in to comment on other people's terms. You can upvote or downvote terms and watch them so that you'll get notified if they change. This term is labeled the vernacular class, which means it can be changed by the owner. The terms labeled canonical class are done changing. There are also deprecated terms, but they too will always be available because historical documents will be available. You can add your term and immediately walk away with an ARK persistent identifier to reference it. There's no problem creating multiple terms with the same name string. This one has 13 alternates, but each alternate will have a unique ARK concept identifier. You can also add tags to terms and import terms in bulk via a CSV file. So you're probably wondering, when do we get a slide on philosophy? Well, here we go. So-called persistent identifier strings don't help much in forecasting persistence. Here's some data, or is it an opaque identifier? We won't know unless someone or some system is willing to associate it with something. An identifier is an opinion, really. It depends on who you ask. In other words, on which name authority you ask. If it is an identifier, it would be so helpful if it looked like a URL, because the name authority includes the domain name, and the HTTPS in front gives us an easy way to ask. The existence of this string tells us nothing, but it looks like something we can ask a web browser about. When we do, we see a page containing explaining that it's an example identifier. What we won't see is that behind the scenes, it returned a 404 not found error status. So this looks like a URL. It returns a page, but in fact, it's not an identifier, at least as far as HTTP is concerned. Maybe someone else has an opinion. So this looks like a proper PID. In fact, it's a DOI, right? Well, no, it looks like one, but it's not. When we click on it, we see a page, but the page tells us that a 404 not found error occurred and that the DOI system has no knowledge of it. This string looks like a PID, but it's not even a valid identifier. So let's try another name authority. At last, a browser returns a page with no 404 error. Okay, now we have a true, valid DOI. You're thinking this should identify trustworthy, citable, scholarly content, right? Wrong. In fact, it identifies a kids' movie. That's correct because it was created by a registration agency assigning DOIs to movies, all movies made in the United States. The point is that you can assume very little about an object or its persistence by looking at its so-called persistent identifier. If it looks like a PID, that's only a suggestion. Persistence is not conferred by a string, prefix, or syntax. That's true whether you're dealing with ARKs, DOIs, handles, URNs, or ordinary URLs. Tools for implementing ARKs can be found in the resources area of the ARK Alliance website. I don't have time to go into the rest of this, so we'll just skip that. There's an important feature called suffix pass-through. It allows a web server to choose, a web server can choose to support this in order to greatly increase the number of identifiers that it can forward. It dramatically reduces the burden of maintaining identifiers by permitting one identifier to stand in for millions. The way it works, given a URL for the stored identifier, if an ARK arrives with an appended suffix, N2T will reappend that suffix or pass it through to the destination during resolution. This is critical for things like the IIIF applications, since the many addressable subparts and formats don't all have to be separately registered, separately maintained, and separately paid for. This final case study uses a visualization from David Glace of the US National Science Foundation iSamples project. It allows us to visit the South Pacific island of Moorea in French Polynesia. Each of the colored points represents a physical sample, and the towers indicate that many samples were collected at the same location. Each sample point has an ARK identifier, which is displayed when mousing over it. Clicking on one of the points brings up summary metadata, which allows you to link back to the original collection. Following that link to the Smithsonian, you can find more details about the specimen with cross-references to analyses, publications, and other material. The interlinking is done with millions of ARKs, and the number of participating collections should grow significantly as the project continues. It's all part of the NSF iSamples project, which assigns identifiers to biological specimens, rocks, and to archaeological artifacts. So that's it. Ready for questions? I have longer versions of this that answer many other questions perhaps, but this it said about 30 minutes. So here we are.
Yeah, that was really good, very interesting, John. I was going to ask you about the suffix pass-through. Do you use that a lot?
Yes.
Okay.
The Smithsonian relies very heavily on this for they resolve things through M2T, and this mechanism is at work for most of their ARKs.
Okay. Yeah. I remember that. Was it YAMZ? YAMZ?
YAMZ, just one word, one syllable.
Yeah, YAMZ. Yeah. I remember that from when we were working together. Sorry, anyone have any questions? I'll stop the recording actually. Or should I carry on recording?
Yeah, maybe. So thank you for your presentation. It was very interesting. I was not aware of the ARK identifiers. I know a bit about the Web ID initiatives. How does it differ from Web ID, or is it the same ID?
Are you talking about w3id.org?
Yeah. Yes.
So W3ID looks a little bit like it's a web consortium domain, but it's actually not related to the web consortium. So it's not w3.org. W3id.org is a volunteer effort with about I don't know, half a dozen to a dozen companies that have sort of pledged to sustain it. As far as I know, we have a listing for, there's a small relationship in the sense that the ARK scheme is registered there, but it's very GitHub based. So if you want to register an identifier, you register one at a time. It may have an API, but the ARK, it's much more, I think it's more for a smaller scale of operation, I think. I don't know that much about it, unfortunately.
Okay, thank you.
Leila.
Yes, I have a comment. I have worked with the w3id.org, and one difference that I see is that because that one relies on a GitHub repository, I see it as a centralized effort. Everything that wants to use W3ID has to be in that GitHub repository. While if I remember correctly, John, one of the differences that you mentioned, not with this one, but with other systems, is that ARK is decentralized, correct?
Yeah, ARK is very decentralized. That's correct.
And how does it work for someone totally new to ARK to get an identifier? What is the process? With DOI, for instance, you just have to become a membership, and there is some affiliation fees, etc., etc. With W3ID, you have to clone these GitHub repositories. So maybe can you give an example?
Yeah, the tool set for ARKs is not as mature as what's available for DOIs. So DOIs, you can maybe familiar with DataCite and Crossref as two organizations that are already set up. They've got customer relationships and billing, and you can sign up for a plan. the ARK world, we had something at the California Digital Library called EasyID, which for a period of time was accepting any customer. You could establish an account and mint ARKs and DOIs from there. They stopped accepting new customers, and so unfortunately that is no longer an option. But I think it will be an option again soon, but possibly from different organizations. The EasyID source code is going through a major refactoring, and we expect it to be released, and it will make it possible for anybody to set up another system that basically turns into a sort of a turnkey way to mint ARKs without having to implement anything locally. So it's a really nice idea to have that, but we don't have that yet, unfortunately. So although it's not a huge lift to implement ARKs, it is a lift and takes a little bit of doing. It's actually fairly easy considering what it's for. I'll mention that there's two groups in Africa. There's a West African and an East African consortium that are talking about being regional service providers. So they're going to go the pain of implementing ARKs for an entire region. Something similar is going on in Latin America with a project called La Referencia, where they're, at least in Brazil, they're thinking of setting up one regional hub for ARKs, and then no one that they serve has to implement ARKs. They can just come to them and it will be subsidized. So these things are in the works.
Okay, so yeah, it's interesting. I know La Referencia because, yeah, I know that there are people from Brazil involved, but it's actually at the whole Latin America level, as far as I remember. So I'm not sure if I follow correctly, but we don't have any other raised hand, right, Nick? No.
No.
So if I think, for instance, in how I get a DOI, I need to go and do a publication process with any institute that can mint DOIs. And as part of this process, they will assign some metadata to the publication, depending on, well, hopefully depending on the sort of publication, whether it's software data or an scholarly article. With ARK, I imagine that you can also, and I think you also mentioned this, that you can use this identifier for any sort of digital objects. But you are mentioning that there will be this service that you go to this EasyID and then you get like the identifier for the object that you want to represent. What about the metadata? Will you also ask some minimum metadata that will be hosted permanently, but ARK system? How does it work?
Well, see, the ARK system, it's just one word, one syllable, ARK, is to test this out. You can, in the chat, I put in the domain name for easyid.cdlib.org. That's a system that I worked on back in the day. It allows, if you visit that, you can actually create test ARKs right there without having a login. So they don't accept new customers, very unfortunately, but you can test it, and in minting new ARKs, you're invited to enter the minimal ARK metadata, which is just who, what, when, basically. Some sense of agency, some sense of date, some sense of a name for the thing. And 80% of the ARKs in EasyID have this minimal metadata. As I mentioned, it's very flexible, so you can actually use the same. This is an illustration, right? So of what will be or could be soon. There's a group in Switzerland that is starting up using the same software, the very sort of early adopters. But you can imagine, you can take data site metadata, for example, and assign it to ARKs. There are many ARKs that actually use the data site metadata profile for the ARKs. So that's a free process, and the ARKs are free. Signing up for DOIs, you're paying roughly $1 per DOI. But the metadata profile or entry looks similar.
Thank you.
Carol.
I was going to ask John, who pays for ARK to run and exist?
It's an all-volunteer organization with 4 working groups, and we invite you all to express your interest. If you want to get involved, we'll happily do that. We see this as a currently the infrastructure, the resolver infrastructure is very lightweight. We see identifier resolution as a almost technically easy problem. I mean, as Nick knows, from at the core of it, it's a simple redirecting mechanism. It's very cheap. It's very easy to set up and to maintain. So CDL is currently hosting that infrastructure, and they're refactoring it to be even simpler than it already is. And we hope to basically establish replicas everywhere. We think it's light enough. We're trying to drive the cost to 0 so that it's easy to sign up and say, yeah, sure, we'll host a replica. The idea is that it shouldn't cost, and we're trying to make sure that it doesn't cost. So the actual, if you register a domain name, you have to go to some domain registrar, maybe GoDaddy or something, and you pay ICANN a fee, maybe $20 a year, $50, could be $100 a year. But we don't believe in that cultural heritage organizations and scientific organizations should be charged anything. So we don't think that's right. So we have our own registry, and it's just operated by volunteers.
That's very interesting, because I mean, we have Gavin here from Elixir, and because we're all Elixir, well, a lot of us are Elixir here, but Elixir Hub. And one of the things that I fretted about a lot when I ran interoperability was PID schemes, that we never managed to nail, PIDs in the data platform in a common framework. We have identifiers.org, but that's the only kind of identifiers activity. But that doesn't actually allow you to generate PIDs. It allows you to kind of try to redirect them. So yeah. That's why I was asking in particular, because I think identifiers is such a critical piece of infrastructure that we seem to be spending an awful amount of money on PID resolvers in Europe, when I'm thinking, well, if there's already one, why are we doing that?
Mm-hmm.
I don't expect you to answer the second question, John. But that was a very nice presentation, John. That's the best presentation I've seen of ARKs.
Oh, thank you.
Very clear, very clear.
Yep.
I think we should distribute that video throughout Elixir, Gavin.
Yeah, I've kept the questions as well. Let me stop it now, because I thought the questions were interesting as well.